Welcome to the Unit 0 Section 2 video on simplifying expressions. So when we're simplifying expression, you must use what we call the order of operations. And we actually have an acronym that's used to help us remember this. And that acronym is PEMDAS. And now you may have also heard of this as Please Excuse My Dear Aunt Sally, to help you remember those letters. Each of these letters stand for something. The P stands for parentheses. The E stands for exponent. The M stands for multiplication. The D stands for division. The A stands for addition. The S stands for subtraction. So this is the order in which you carry out operations. You're going to do everything that's in the parentheses first. Anything that's inside grouping symbols. It may be parentheses, it may be brackets. Then you're going to move on and evaluate any terms that are raised to a power. Then you're going to multiply and divide, starting from the left and going to the right, so whichever you come to in whatever order it is. And then addition and subtraction you will also do from left to right. Now keep in mind, if you have a fraction, so say you have something on the top of a fraction and something on the bottom of a fraction, that fraction, the numerator and denominator, acts as grouping. So that will be something that you will perform first, is your parentheses. So a good example of that is here in the first example. So we're going to simplify each of these expressions. Now note, you need to show your work step by step to receive partial credit when you do problems like this. So let's take a look at number 1. We have the top here. This is grouped on its own. What's in the bottom, in the denominator, is also grouped. 1 plus 2 squared we are going to treat before we do something else, okay? So the 5 is just what it is. It's on the top. Then we're going to do what's on the bottom. Order of operations tells us that we need to do the exponent before we add. So 2 squared is 4. Then we're going to do 1 plus 4, which is 5. Then we will finish off with 5 divided by 5, which is 1. So that is the answer for the first one. For number 2, we're going to start off with our parentheses. So we've got 4 squared minus 4 minus 2, which gives us 2. Then we're going to do our exponent. 4 squared is 16. And then finally we're going to subtract. 16 minus 2 is 14. For number 3, we're going to do each of our parentheses first. So the first parentheses, we're going to add. 1 plus 6 is 7, plus 4 is 11. 6 minus 2 is going to give us 4. And then 11 times 4 gives us 44. So remember, when you have two parentheses sitting next to each other, what you're doing is multiplying. All right, for number 4, we're going to take care of the top first. So 8 plus 3 is 11. So we're going to go from left to right. I'm going to show you these steps one by one. So 11 minus 5 gives us 6. 6 plus 6 gives us 12. And then 12 divided by 4 gives us 3. For number 5, we have 8 minus 2 in parentheses, so we'll do that first. 8 minus 2 is 6. So we've got 6 times 2 on the top. And we've got 2 plus 2 squared on the bottom. 2 squared, our exponent, comes next. So 2 squared is 4. Now we're going to multiply 6 times 2 on the top, which is 12. 2 plus 4 on the bottom gives us 6. And 12 divided by 6 gives us 2. And then finally for number 6, we're going to do what's in the parentheses first. So we've got 5 plus 6 minus 3 gives us 3. 3 minus 3 gives us 0. Next step is the exponents. 3 squared is 9. And here I don't have to write the 0 because minus 0 doesn't do anything. So I'm just going to leave that off. 5 plus 9 is 14. Okay, so now in evaluating expressions, we're going to replace each variable. Variable is a letter that takes the place of a number until we know what it is. So we're going to replace each variable with the value that we are given for that variable. Okay? Then we are going to perform the operations using the correct order of operations. And then when two variables are next to each other, it means multiply. Okay? So keep that in mind. When you have two variables sitting next to each other, you're multiplying those variables. If you have a variable next to a number, you're multiplying that number and that variable. So let's evaluate each of these expressions. So first thing we're going to do is substitute in. We know that k is 5, so we're going to substitute 5 in here and 5 in here. And then h is 3, so we're going to put a 3 there. From here, it's just like what we did on the previous page. We're going to follow the order of operations, doing parentheses first. 5 minus 3 is 2, and then 5 minus 2 is 3. For number 2, we have h is 4, k is 6, j is 6. So we're going to do multiplication first. 4 times 6 is 24. And then 24 minus 6 is going to give us 18. Number 3, we have the variable b, which is 5. A is 1. B is 5 again. And here we're just going to go left to right. 5 minus 1 is 4. 4 plus 5 is 9. For number 4, we have 6 times x, which is 2, y, which is 4. So 6 times 2 is 12. 12 times 4 is 48. For number 5, we know that x is 4. X is 4. Z is 1. We do what's in the parentheses first. So 4 plus 1 is 5. Then we do our exponent. 5 squared is 25. And 4 plus 25 is 29. Number 6, we have 4 for B. C is also 4. And then we're dividing by 4 on the end here. So let's follow our order of operations. 4 times 2 is 8. 8 times 4 is 32. And 32 divided by 4 brings us back to 8. For number 7, y is 4. X is 5, y is 4, x is 5. We just plug everything in. So we do our exponent first. 16 plus 5 plus 4 plus 5. And then we go left to right. 16 plus 5 is 21. 21 plus 4 is 25. And 25 plus 5 is 30. And then finally, for number 8, we have 4 plus k is 4. So we've got 4 squared. And then j is 1. So in parentheses, we have 1 plus 1. So let's do what's in the parentheses first. Got 4 squared times 2. Then let's do our exponent. 4 squared is 8. No, I'm sorry. 4 squared is 16 times 2. 16 times 2 is 32. And 32 plus 4 gives us 36. All right, let's move on to the next part of simplifying expressions. Let's know how to identify parts of expressions, okay? So let's talk about coefficients, terms, like terms, and exponents. Coefficients, a positive or negative number multiplied by a variable. All right, terms are a single number, variable, or the combination of a number of variable. And remember, a combination of a number and variable, such as 3x, we're saying 3 times x when we say 3x. All right. Terms are separated by either an addition or subtraction sign. And if you want to say plus or minus sign, that's perfectly fine. Like terms are terms whose variables and exponents are the same. Okay, so variables and exponents are the same. And all the variables and all the exponents have to be the same. Exponents refers to how many multiples of the base you have. Okay, so for example, say x to the third. This x is your base. And this 3 is your exponent. X to the third is the same as saying x times x times x. All right, now that we've got a little bit more terminology, let's do some examples. Let's first identify the coefficient for negative 3x squared. The coefficient is negative 3. Our variable is x. Our exponent is squared, so we've got an x squared. And then the number of terms, we've got only the 1. For number 2, we have 2 coefficients. 6 and 7 are both coefficients. We have a variable x. We have an exponent of 1. Okay, technically we have an exponent of 1. And the number of terms we have is 2, because 6x and 7x are separated by this plus sign. For the third one, we have 3 coefficients. If there is not a number in front of a variable, that coefficient is understood to be 1. 3 and 4 are the other coefficients. We have the variable x. Our exponents, we have an x squared term. And we have 3 terms. 1, 2, 3, all separated by these 2 plus signs. Our coefficient for number 4, negative 1. Our variable, we have none. Our exponents, we have none. And we have 1 term. Coefficients, 4 and 2. Our variables, we have x. We have a x to the third, so our exponent's 3. And our number of terms is 2. And then finally here, coefficient is 5. That's the number on the front. Variable is x. Exponent is to the 7th. And we have 1 term. So for this last set of examples here, let's identify what the like terms are. We're not going to combine them here. We're just going to identify what they are. So here we have two x squared terms. So we got 2x squared and 6x squared as our like terms. 5x and 9 don't go with anything. For the second one, we have two a squared terms. So 3a squared and negative 5a squared. If you have a minus sign in front of a term, you've got to include the minus because it's the same as saying plus negative 5a squared. For number 3, our like terms are 3xy and negative 7xy. For number 4, our like terms are negative 3n to the third and 9n to the third. For number 5, our like terms are 10 and negative 5 because neither of these numbers have a variable with it. Number 6, we have 9x and 4x, but we also have 5 and 3. 9x and 4x can be combined to give us 13x. 5 and 3 can be combined to give us 8. Number 7, we have 7x squared y. Do we have another term that's got an x squared and a y? Well, this one does not have an x squared, so we can skip that one. This one has an x squared, this one has a y. Even though they're not in the same order, they are still like terms. Because if you think about it, you can multiply things either way. You can say 3 times 5 or 5 times 3. Both are going to give you 15. So that's why this works. And then 8xy doesn't go with anything. Let's look at number 8. 3s to the third t squared. Do we have another s to the third term? Well, we do here. And there's a t squared. So we have 3s to the third t squared and negative 6t squared s to the third. Let's see if we have another s to the third term here. We do on the end, and there's another t squared. So we also have s to the third t squared on the end. The other two terms don't go with anything. So in this one, the first term, the third term, and the fifth term are all like terms and can be combined. For number 9, we have x squared y. We don't have another x squared y term, so this one nothing goes with. We have a y squared. Let's see, we have a y squared here. We have a z and a z. We have two terms that go together, 4y squared z and 3zy squared. And we have an x squared term here with a z. There's an x squared term here with a z, but there's a y squared with this one, so they don't go together. So this is as good as it gets. For number 10, we have a PM here. We have an MP, which is the same as PM, so we can say PM and 7MP. Here we have the m squared p squared. Nothing else has an m squared p squared. Here we have a pm squared. Nothing else has a pm squared. And this is p squared m. So these are our two like terms that can be combined. Nothing else can be combined. Okay, so that's it for this section. Okay, next section we're going to do a very brief section on the distributive property and how that works.